morning, everyone. Not sure if, this is the starting time, so I guess we start. So I'm going to talk about AI, right? So who haven't heard any talks about AI recently? Let's see how it works out. So before we actually start, actually, who is actually using day-to-day at work any sort of AI? Not everyone, but at least half or more. Okay, that makes sense because it really is going quite fast. Okay, so first, let's start from a story, right? So about 200 years ago, that's what most of the people on Earth did, right? So some variation of this, some sort of agriculture. And about 200, 150 years ago, there was introduction of these steam engines, so basically mechanical power. But those steam engines, this particular type of engines, were only relevant for large factories, right? They were not actually accessible to regular farmers, right? So only large factories that produced a lot of the same thing could actually afford to build an engine like that. What really brought the change was this, a tractor. So internal combustion engine together with new types of fuels and all kind of other innovation. But basically, this allowed the farmer to bring a machine to a field. And what this led to is massive replacement of agriculture workers towards industry and services. Right, so if you look from 200 years ago, over 75%, or around 70-75% of people worked in agriculture. Today, it's about 2%. Now, really, the question is this what is happening now? And it's quite obvious that those waves of innovation, they're not stopping, so there's always a new wave of innovation. It's clear that this is not the first one and not the last one. And we sort of in the middle of this transition from, there was an industrial revolution where we replaced the physical labor with machines. Now we are replacing our brain power with machines. And of course, later on, we expect to have smart machines that will actually be autonomous and do things without us being involved. But this is quite clearly is happening, right? But what's interesting is that it's happening much faster than any previous technology. So if those technologies were perceived as super aggressively fast, so AI is even faster. Not that it doesn't exist for 40 years, but actual adoptions that started from around 2 years ago with ChatGPT, and now it's basically everyone is using it. And it's quite clear that there's a lot of value to get out of it. I'm not going to go through this. It's not entirely obvious where all the value lies, but it's fairly obvious that there is a lot of value to get out of it. So the first question really is, will it replace developers? Who thinks it will? Only few people, actually two. Is it because you're afraid or because you don't really, no one believes it will replace developers? Yeah. It's partially for a good reason. So let's try to answer this question. First, this report from a company called Cotu, something, they say basically we are moving towards full autopilot. So from assistance, human plus AI, towards full autonomy. And majority of white-collar jobs will actually move to full autonomy. So it's not just about developers, it's the lawyers and scientists and all kind of different disciplines. And So I read this book from Garry Kasparov in 2000 that he said, basically, the best out of both worlds is when a machine helping a human, right? This is the best thing. But actually, this report says, at the end, the machine will beat everything. Like with or without human, it doesn't matter. The machine is always beating the human. So actually, the argument is that there will be full autonomy and not augmented reality. Right? This is one point of view. And there is sort of transition from, you can perceive, like, think of it like self-driving car, from a developer doing all the work to developer instructing the machine, developer supervising the machine, and then eventually the machine doing all the work and developers are only observing and governing. And then what's the role of a developer? So GitHub CEO says that we will become more of a system thinkers and high-level architects, right? So we will guide the machine, we will express the intent and observe the direction, but we will not actually write code. And Andrej Karpathy says that English is the next programming language. He is one of the lead people in self-driving cars in Tesla, and he's a person who actually claimed or invented the term vibe coding accidentally. He didn't mean it. Right? And then Sundar Pichai says that 30% of the code already today is written by AI in Google. And Anthropic CEO goes even further and says 90% of all code will be written by AI within 3 to 6 months. And Elon Musk says that, just drop all your code inside Grok and it will do whatever you need to do, right? That's what they do. And then people like, if you don't know him, it doesn't matter, but this is quite common argument today, is that basically he says the AI is coming after coders, but not after welders and builders and stuff like that. So actually, he thinks that we need to teach kids to weld and do other physical tasks. But there are other opinions. Like Bill Gates says that for 100 years we're not going to replace developers. A bit of a party pooper, right? And the current state of the thing is that the vibe coding can actually, where 2 engineers can create enough depth to replace 50 engineers, technical depth. Right, so what's the actual answer? It's not clear what the answer is. Will the AI replace the developers or not? But what is clear is that the only discipline in software development that is growing is AI-related jobs. And it's jumping 600% this year, compared to all the other disciplines going down. So they sort of suggest that, you can ignore it, you can believe it's never going to happen, but actually it already happened. And then this report says that actually there is a new discipline called AI engineer. Is there any AI engineer here? No. So this is not exactly ML engineer, because that actually existed for a very long time. It's a new discipline where we're actually learning or getting maximum out of AI systems. So this is a new direction, and as we develop the AI, as it becomes more autonomous and more helpful, then new disciplines, new ways of working will rise. So what kind of software are we going to build? Again, everything I'm going to say today will have no answers, just questions, right? Like you saw before, will AI replace software developers? I actually don't know. It's hard to say because AI is going very fast up, but it's not clear where it's going to slow down. But it has to, right? They're so far in the world, there never was a technology that didn't slow down eventually. And the argument that this one is the first one that will continue growing forever, it may happen, but it never did. So based on the past experience, I would say likely it will slow down at some point too. So what's the future of software? I mean, before I go into that, it's very important to understand that most of the software is built by first big tech giants like Google and Microsoft. Then there is a lot of software companies that they were born software companies. They build software like Monza, Datadog, whatever. And then there are large enterprises that they're not software companies, but they're so big that there's a lot of internal processes and automation, and they have a lot of money to invest to actually build their own software teams and build their own custom software. What never happened before is the smaller non-technical companies. Think of your local flower shop or local welding company. They actually never had access to custom software. Now, they could buy software products, like for accounting and stuff like that, but they could not have access to custom software development. They wouldn't have platform engineers, software development engineers. They could hire a website developer for a month, but that's as far as their budget could go. So I'll talk about this a bit more, but first, let's talk about the bottom one. This is what we do, right? So these are the companies that actually build software. Of course, I can go into a lot of technology and start talking about, you better do this. So actually, I'm not going to talk about this. There's a lot of ways to build platforms. It's not very different. This is a good article by my colleague Michael Mueller. So yeah, platform is a platform, but that's not the point. I think the point is that the architectural, we're talking here about cloud native, and I'm doing cloud native since before it was called cloud native. And we're talking about microservices and cloud and containers and all that stuff. But actually, this is changing. There is a new principle of agents. Now, agents are not dramatically different from microservices in terms of how they run, but they perform very different things. So they can analyze questions, they can speak normal human language, and they can take actions. And they can access your data. So the big difference is that it's not, you don't need to define precisely the question and the answer and the format of everything. They actually speak English. That's a big difference. And you don't need to normalize the data too much or create schemas and stuff. So, and this is another sort of example of things you can create. An agent, this one is auto-reply on emails that Michael created based on N8N, which is a very nice tool. It's a platform for agent development. It's actually not that complicated, so it monitors his Gmail and then goes to accesses to his previous Gmail, then a bit to internet, collects information, creates a draft of email to respond, puts it in Slack, and he can say yes or no. And if yes, it saves the draft in Gmail, and he can just send it. So it basically means that he automatically answers his emails without actually reading or understanding, just reviewing that it is correct. So it monitors the system, it accesses the data and the internet, and it takes actions, right? And there is a human in the loop that actually accepts or rejects the change. This one, if you really want to understand agents, this is probably the best video I have seen, which is from Camunda, which is another automation tool. He explains about basically a similar concept about a person goes to a bank to ask for a loan, right? And when he asks for a loan, an agent will understand the query, which is written in normal English. Then we'll go to internal systems, understand the credit score and how much money is available, and we'll create the recommendation, send to a human in a bank, and a human in a bank will either accept or reject it, and then the system will send automated email with QR codes and everything. So basically, the entire process is fully automated with a human in the loop for approval. And there are a variety of different agents, which is, again, I won't go into different things, but the point of agents is that they're not just understanding what we are saying, but they actually take actions. They sort of The reason they're called agents is because they're sort of replacing human agents. So they become extension of your team that are doing things that normally humans would do. And there's a lot of ways to get into learning how to build agents and what they are. This is a very good example for LangChain, which is quite famous company in building AI software. And there are a lot of tutorials and ways to learn how to build agents. So this one, I just studied it yesterday because it actually was released 2 days ago, which is ChatGPT agent. Have you heard? Anyone heard about this? Yeah, quite few. Okay. So I think the difference is that ChatGPT, the chat is that when you say something and then you explicitly need to choose what kind of thing it's going to do, either operator do a task, or deep research to evaluate all kind of things. So the agent is actually doing all of it. So you talk to it, you ask a question, it has ability to take actions, it can go into deep research mode and research internet. It has actual browser, so it can browse internet as human would do and understand like not just text but also visuals. It has a virtual machine to write and execute code on it. And it can operate in visual and text mode, and it has memory across different sessions. So essentially, you can talk to it. It can go to internet, browse it like the human would do, write some code, execute it in a VM, return the result, and if you confirm, it will actually take actions like book flights or send an email. And what they say that ChatGPT agents already now performs about 50% of the times better than any human in any discipline. Who is scary now? Scared. Yeah. But this is not the end of it. This is definitely not the end of it. So the next significant step is that actually we are talking all the time about LLMs, large language models. Actually, the real change is going to happen when we move away from LLMs to SLMs, small language models, which means that when we actually ask a question, we don't use a massive something like ChatGPT or Gemini, massive models that are very expensive, but there will be a bunch of dedicated, small, domain-specific models that train to answer small questions very, very well. And they will be very cheap, and every agent will use the right model to answer the question. So we actually don't need those generic LLM machines for everything. We do need them for some tasks. And in terms of the work that we are going to do, but generally there is a significant change from thinking in the past. Now still, thinking is the fast part, and coding and deployment and maintenance is the long part. With AI assistants, it actually flips around. So the thinking is the important and long part. The guiding, expressing the intent, and making sure that what is built is correct is actually what's important. And writing code is actually fairly fast, assuming that AI can actually write code. So just a bit about the platforms. So what we actually want to see in the platforms is that the platforms, they need to reduce cognitive load and basically collect all the reusable components so everyone can use them. So over time, we want to put more and more functionality inside the platform so developers don't need to do the same thing over and over again. What is changing is that it's not just so because writing code and deployments and things that we are talking a lot about in cloud native space, they become less relevant in AI native space. What is relevant in AI native space is data management and orchestration of AI specific components and explainability and security and all kinds of things that are more relevant for AI native space. So that's what needs to go into the platforms. So what we need to build as platforms is more of the things that take away this stuff from the developers, not the deployment. That will be sort of hidden away and become commodity. And very specifically, a very important point is explainability and human in the loop. Like I said before, every time there is a human in the loop, because we don't yet trust the AI systems, we need to build the trust, and we need to make sure that they don't do something terrible and it's too late to fix. And to be able to actually be involved in the loop, we need to actually understand what they're doing, which is not trivial. And I'm not going to go over this, but basically the patterns that we are using to develop software are changing now. So this is going into my next book, which I'll share in a moment. But there is a lot of new design patterns that are being introduced as part of AI native world. And they're somewhat different from what we have seen before, and this is what we need to be learning. Right? And then just a few words about this top part. Back to those companies that never had access to software development. What actually happens, this is a very good example of such company that we visited in Denmark. They build this kind of liquid tanks. Right? They're welders, they're builders. They're about 50 people. About a third of their time they spend on digging documentation and figuring out which standard to use. Right? There is a lot of this bunch of tools in accounting and sales and marketing, a lot of waste, a lot of bureaucracy, a lot of stuff that can be automated. And until now, they couldn't actually do automation that we would normally in software companies, we would do natively. So they actually now have access to custom software development, because the same system that would take to build maybe 3 people for a year now takes 1 person for 3 weeks with assistance of AI. So we can actually collect their data. This is an example, another example that Michael built. So this is integration of Atlassian tools with Slack. So this is something that basically, if you want to, so it connects to LLM, to Gemini, and there is an MCP client from Atlassian, and basically you can look from Slack for pages in Atlassian tools. It doesn't take actions yet because the MCP server doesn't support it, but it's quite simple and effective way to automate a lot of tasks using normal language, English or Danish in their case. And the last part is about transformation. So this change is different. It is sort of similar to cloud-native transformation, and the main reason is because the architecture and the way of working changing so much that the entire company has to change, not just introduction of a new tool. Let's just take ChatGPT agent, implement it, and we are good to go. No, it involves organizational change, it involves a lot of different internal processes change, the same what we experienced in cloud-native in the last decade. And the good thing is that we actually have a lot of experience in transformations and waves of innovation. So this is a slide I used in 2015 with the argument that microservices was at that point the next wave of innovation, and we were talking about technology X, which is here, apparently. So this is not new. I actually even wrote a book about this about 6 years ago, which the whole point was that when we go through transformation, we start small, build some POCs, experiment, learn a new technology, then build the MVP, and then scale, and in the same time we scale down the old world. Right? This is the right way to go through transformation. Start small, experiment, learn, scale, scale down. And that's the part of the next book is basically, it's exactly the right way to do it. It is the only way to go through transformation. There are 6 sort of modes of operation. You always should be pioneering, researching, and experimenting. If you don't do AI pioneering, if you don't look into AI and research and learn, you are missing the train. And as you have seen, the world is changing, and you have to get involved. It doesn't mean you need to go all the way to production with AI, but you have to be ready. And there are very particular ways of things, ways to actually do this beginning, this pioneering stage, which is separate teams in sandbox environment, building POCs, and developing a business case. Once that is ready, then the scale starts. And each stage has its own patterns and its own activities and ways of working. And it's important to change over time. So all this is going to this new book, which is called From Cloud Native to iNative. And if you want to download a small snippet from the book will be out in a couple of months. And that's it. Thank you. And still 3 minutes for questions. How it works. Any question? Yes.
We were talking about transformation. How would you suggest for a company to start if they are not transforming but starting from scratch?
Okay, everyone's starting from scratch at some point, right? I think what's important is not, one of the biggest mistakes is to go for it with 30 people, massive budget. That's not how you transform. What you do is you have a small separate team on the side that they do the research. And in the beginning, it's not even commitment for a transformation. It's just a research. They learn, they experiment, they look for business case, they look if it actually needs to, like it's something that is valuable for the company. Then once there is a business case, you always have like a transformation champion, somebody who is pushing for it and researching it. Once there is a business case, there is executive commitment. Normally, there is one very senior person, normally CIO or CTO, that supports this transformation. A company commits to that transformation. And generally, there is a very, very important rule. You never do 2 transformations at the same time. Like there is this concept of transformation fatigue, right? Companies go from one transformation to another, run 4 in parallel. This is a terrible thing to do. None of them actually is transformation, right? And from that point, the whole purpose is to actually transform until you get to maturity. Most companies today using cloud native, they sort of transformed, but they actually never got to maturity. You talk to like how you use Kubernetes, how do you have platforms? Do you have platform as a product, like in previous talk? Why we are still talking about this? Why companies didn't already get into that mature state? Right? Start small but once you are in transformation, your goal is to finish it as soon as possible. Yes? Right. Reducing cognitive load for reviewing code by AI. Yeah.
So for example, I prompted Cloud to write me a script and it outputted like a 1,000-line script,
Yes.
right? And I'm taking the same amount of time reviewing the code, then I had to make it myself, right?
Sure. And then there is this argument that because this is a very it requires a lot of experience, so it means that only senior engineers can do it, and then there is no point in hiring juniors, right? Because they cannot do that. Basically, this is a temporary state. Like the best thing you can do is ask AI to review AI work, right? And it's not always practical because sometimes you get the same like hallucinations and the same problems, and it's not better. But we are in this sort of interim period where not everything is perfect. But basically, at this point, it requires a lot of expertise. You need to go through, you need to actually fix the problems yourself. And for this purpose, you need to understand what's going on. But you consider it as an investment into the future. Like you're teaching the LLM. Maybe indirectly, they're not learning from that particular exercise. But overall, you create new code, and that will feed into next model and next model. And over time, the code will become better, and there will be tools that you will use to review the AI, because you will not be able to understand directly every line of code, because it actually doesn't make any sense to write code in the way humans write it. Like, there's this video of 2 digital assistants talking to each other, if you have seen it. Like one says, I'm representing this person, and if you haven't seen it, it's very cool. I need to book tickets for for a person I'm assisting, and then on the other side, there's another digital assistant, and then they start talking. I'm like, oh, you are also AI, and I'm AI. And then they switch to different language, they're talking directly in like whatever, like noises. So we cannot understand what AI is going to do the same way as we don't understand assembly anymore, right? Hope it answers the question. So that's it. Thank you.
Thank you.
Thank you for coming.